Hello friends, today we are going to have an example on anchored bulkhead. So you have this anchored sheet pile having the anchor rod at a depth of 1 meter from the top, and the total height of this sheet pile is 6 meter, and this is the depth of embedment. The properties of the backfill is phi 30 degree and gamma equal to 20 kilonewton per meter cube. And below the dredge line, the properties of the soil is same as the properties of the backfill. So phi and gamma remains unchanged. So this is in a granular soil, and we need to find out the depth of embedment. So we have to find the depth of embedment, and for that you need to draw the pressure distribution diagram, which I have already explained to all of you in my previous video. So pressure distribution diagram can be drawn very easily, and from the pressure distribution diagram you can find out this, and also you need to find out the maximum moment across the length or height of the sheet pile. So these two things you will have to find it out. So here properties are known to you. So the pressure distribution diagram, how it is going to change, that we will like to see over here. So draw the pressure distribution diagram. So now here this is the anchor rod having force in the anchor rod as Fa, and because it is a granular backfill, it is going to be hydrostatic pressure like this, and then it is going to change like this. So this is the passive pressure, and this side it is the active pressure. So friends, draw the topmost point as A, bottommost as B, and this can be taken as C, and or this can be taken as C. Dredge line we can take it as D, and this point we can take it as E. Naturally, the distribution of the force and everything we will need to calculate it. So depending upon the value of phi equal to 30 degree, the value of K will be 1 by 3, and the value of Kp will be 3. Therefore, Kp minus K equal to K prime will be 2.67. So now here, what would be this pressure? So PA, the active earth pressure at D. So calculate active earth pressure at D. This will be given by the, there is no water table here, and therefore you can find it out as K into gamma into H. So it becomes 1 by 3. So this becomes 40 kilopascal. This becomes 40 kilopascal. Now, let's say the distance between D and C is A. So, A, you can calculate it. So, calculate now. A equal to PAD divided by K prime into gamma. Therefore, this becomes 40 divided by 2.67 into 20. So you can calculate it, and you can also find out this value. Here the passive pressure at B will be K prime into gamma, and if B to C, this height is capital Y, then into capital Y. This I have already explained to you in my previous video, and therefore this component you can calculate it. K prime gamma into Y. So K prime is 2.67, gamma is 20 into Y. So if you calculate, you can get this value. Therefore, you can find out the resultant of this pressure distribution diagram that will be giving you the resultant passive thrust or passive resistance RP. And the area of the active earth pressure distribution diagram will give you, this resultant will be the active thrust P. And you can always find out the distance of PA from C up to here, and that distance could be taken as Y bar. And all the moments are to be taken about the anchor rod. So this distance can be taken as Z bar. So here, let us calculate. So friends, it is 2.67 into 20, 53.4. This is equal to 53.4 times Y. So this is known to us. Okay. So therefore, we can compute A also. A is 2 divided by 2.65. So 2 divided by 2.67. 0.749 or approximately 0.75 meter. So this is 0.75 meter. This is also known. Now, RP you can calculate it. The resultant of this passive force. That means the diagram BCB1, its area will be half into base into height. So this, if you simplify it, 53.4 divided by 2, 26.7. Y square. So friends, the magnitude of this force is known to us, RP. So RP equal to 26.7 y square. Y is not known to us. That we have to find it out. Now find out the magnitude of PA. So PA will be the area of active earth pressure diagram, that is ACD1, that is the complete area. So what would be the area of the, we can divide it into ADD1 and DD1C, two diagrams. So ADD1 will be half into base, that is 40, into height, that is 6 meter. So this becomes plus another DD1C, this area will be half into base is going to be same 40, and this height is 0.75. So if I calculate it, this becomes 120 plus 20 into 0.75 equal to 15. So total becomes 135 kilonewton per meter length of the sheet pile. Therefore, PA is known to us. There is 135, 120 plus 15. Now, you need to find out Y bar, because when you need to find out Z bar, let us find out the location of PA with respect to C. So from here, what is the vertical distance? Let it be as Y bar. So Y bar, find Y bar, the location of PA. So this will be Y bar equal to, so Y bar equal to 120 P1, this diagram. This will be acting from C at 0.75 plus H by 3. So it will be 1/3 of the height, that is 6 meter. That means 1/3 of the height plus P2 is here 15. So plus 15. Now this force is 15. Now from C, it will be acting at a distance of 2/3 of A. So 2/3 of A divided by 135. P1 plus P2. So P1 Y1 from C plus P2 into Y2. We make all this as P1, all this P2. So P2, Y2. So simplify this. So 120 multiplied by 2.75 plus 15 this y bar therefore comes out to be 2.5 meters. So friends, there is going to be 2.5 meter. So we have to calculate Z bar. Z bar is the distance between the anchor rod and the point of application of the active thrust. And this can be easily computed because you know that this is going to be from here to here. It is going to be 5 meter. Total is 6 meter. So 5 minus this distance will give you the value of Z bar. So you can just deduct it. So from here, it is going to be 6.75 or 5.75 from here. So 5.75 up to the point C and minus y bar. So y bar is, you have already calculated as 2.5. So this gives you 3.25 meter. So Z bar we have been able to calculate as 3.25 meter. Having got this, now you can take the moment about the anchor rod. So sigma m about the anchor rod, that is point E, must be equal to 0. So one of the force is going to be Rp here. So Rp, the passive resistance multiplied by the distance up to point E. So this is going to be from here to here, it is 5 meter plus 0.75 A. So Rp into 5 plus 0.75 plus, there is going to be 2/3 of y. 2/3 of y. So Rp is going to create an anti-clockwise moment. Then you have got another force, that is Pa, which is going to have a clockwise moment. So minus Pa into the value, that is Z bar, must be equal to 0. Or What is the value of RP? RP is 26.7 y square. So 26.7 y square into 5.75 plus 2/3 of y minus 135 PA into Z bar is 3.25 equal to 0. So this is the final equation that we need to simplify it. So if you simplify it, or we will be getting 17.8 y cube. This is y square into this will be 17.8 y cube plus 153.52 y square, and this term, if you multiply it, it will be minus 438.75 equal to 0. Now, this is a cubical equation. So, polynomial equation, you can feed it into your calculator and therefore you can find out the value of y. So, let's have our calculator and calculate it. So, you can go to the equation, and if you go to the equation, in equation, go to the polynomial and take the cubical equation. So the value of A is 17.8. So put it. Then value of B is also known to you, 153.52. And the value of D here is 438.75 with negative sign. And therefore, the value of Y, we are getting it as 1.56. 555, so we can say y equal to 1.56 meter. So the value of y is here 1.56 meter. So y is known to you. Therefore, the depth of embedment will be y plus a. So this will be 1.56 meter plus 0.75 meter. So this you can calculate. This will give you 2.31 meter. So the value of D's depth of embedment is now equal to 2.31 meter, right? So D to be provided. Therefore, D provided is going to be 30 to 40% more than the D calculated. So 2.31 to get a factor of safety equal to 1.5 to 2. So 1.3 into 2. So let's calculate this. Calculate 1.3 multiplied by 2.31. This gives you 3.003 meter. So this is the value of D. That means you can say it is going to be approximately 3 meter. Now, once you calculate the depth of embedment, this D is known to you. So D provided is going to be 3 meters. This is the answer. So one of the answer is going to be this. This is the first part. The second part is to calculate the maximum bending moment across the height of the sheet pile. So let's calculate now. So the next part is calculation of this. Z bar we have already calculated as 3.25 meter. So let's now calculate the maximum bending moment. So the maximum bending moment, before that, you must find out the value of force in the anchor rod, FA. So force in the anchor rod, FA, can be found out, can be obtained by applying the equilibrium equation. Sum of all the horizontal forces must be equal to 0. Now RP is known to me. So you calculate RP. RP is given by 26.7 y square. Y is already known to you. So you just substitute it in the equation. The value of y, which you have found out as 1.56 meter. So 26.7 multiplied by 1.56 square gives you 64.97. So 64.977, this becomes 64.98 kilonewton. The value of RP, this is known to me. So RP is going to be 64.98 kilonewton. So this is known to us, and therefore if I apply this, FA is acting this way, minus 135 plus RP, that is 64.98, must be equal to 0. Therefore, FA equal to 135 minus 64 point this will give you the value of FA, and that comes out to be 70.02 kilonewton. So friends, you have got the value of FA also. So FA equal to approximately 70 kilonewton. Having got the value of FA, now we can find out the maximum bending moment. Now calculate a max. So the maximum bending moment will be where shear force becomes 0. Let's say shear force is going to be 0 at a height h1. This will fall between the point E and D. So it will be between E and D, this point. So let's say the point is somewhere at a height h1. So it is at this location. So if it is at this location, we can find it out. Let's say this is at a height h1. So you can find out the forces that is going to act. The shear force will be FA, that is already known to you. So, and at h1, from A, shear force equal to 0. Let's say that point is F. So this is the point F. So at F, the shear force equal to 0. So what would be the force? The force, you know it, that half K gamma H1 square, that is the force, minus, you can take it FA equal to 0, and therefore H1 square is 2 times FA divided by K into gamma. So this H1 we will be able to calculate, and this is going to be 21.21. So 2 into FA is already known to you, 70.02, and divided by K is 0.33, gamma is 20. So just substitute all the value, and FA, and you will be able to get H1 square. Therefore, this implies that H1 will be under root 21.21. So under root 21.21 gives you 4.6 meter. So the value of H1 is 4.6 meter. Here the shear force equal to 0. This is the point F. Now at this point, what is the bending moment? That is going to be the maximum bending moment. So in order to calculate the maximum bending moment, now let us find out M max. So we can calculate M max equal to this. This will create a clockwise moment, Fa. So minus Fa into H1 minus 1. So that becomes the moment, H1 minus, this is 1 meter. Anchor rod is provided at 1 meter from the, so H1 minus 1 plus half K gamma H1 square into H1 by 3. This is the magnitude. Now H1 is already known to me. So H1 is 4.6, and therefore this becomes minus 70.02, and H1 4.6. So it becomes 3.6 plus 0.5 into 0.33 into 20 into H1 4.6 cube divided by 3. So if you calculate it, you will be getting minus 70. This gives you minus 145.65 kilonewton meter. This is the magnitude of M max. So the second part, this is the second part. So this is going to be minus 145.65 kilonewton meter. So friends, by taking this simple problem, and applying the theory of anchored bulkhead, which has been explained crystal clear in my previous video, you are in a position to find out the depth of embedment. You are able to find out the maximum bending moment. Thank you very much.